So today begins with solving systems of equations. So first of all, we're going to start by defining a system of linear equations. And we're going to start out with what is a linear equation. And a linear equation is just an equation for a line. And an equation for a line can look a couple different ways. We can either have y equals mx plus b, or we can have ax plus by equals c. So it can be written in either of those two ways. Now, what is a system of linear equations? This is two or more equations in a set. And it might look like this. Now here's what it means to solve a system of linear equations. So first of all, we've got a system of linear equations right here. And what we're going to do is, in both cases, we've got two equations, we're going to graph them. I have these here graphed for you. So these are the graphs of these two equations. A solution for a system of linear equations is this point. It's the point where the two lines intersect. It's the one point that they have in common. All right, so in this case, the point 3, -1 is the solution of the system because that is the point where they intersect. Now, we've got to get to how do I solve a system of linear equations. All right, and there are 4 methods to do this, 4 different ways, and you, once you learn all of them, can choose whichever method that you want to solve a system of linear equations. You can do it by drawing a graph and, just like this, finding the point of intersection, okay? You can use a process called substitution. We are going to do that today. You can use a process called elimination. Some books call it addition, same thing. We're going to do that tomorrow. And the last one we maybe will do later on this year is called matrix row reduction. So we're not going to cover that in this unit, but it is also another way to solve a system of linear equations. So we have for our homework tonight worksheet number 1. And so let's get out worksheet number 1 and let's go through the first one together. And this is an example of solving a system of linear equations by graphing. Now remember, you know how to graph a line. You can either find 2 points on the line, like the x-intercept and the y-intercept, or you can use the slope-intercept form of the line, y equals mx plus b. You can graph the y-intercept and graph the slope. That's what I'm going to do here today. So on the first one, to get this in the form y equals mx plus b, I'm going to subtract 2x from both sides. So what I have is y equals -2x plus 3. So my y-intercept is the point 0,3 right here. And my slope is -2. Now, -2 as a fraction is -2 over 1, which means I'm going to go 2 down and 1 to the right. 2 down and 1 to the right. 2 down and 1 to the right. And I could keep doing this, but 4 points is enough for me to draw this graph. So there's my first line. Now here's the thing about doing this particular method. You've got to draw really nice graphs, because if you don't, you're not going to know what that point of intersection is. So let's do the next one. And to get this in the form y equals mx plus b, I want to divide everything by 3. And so what I get is y equals 1/3 x minus 4. Now the negative 4 is my y-intercept, so that is here. And my slope is 1/3. That means 1 up and 3 across. So 1 up, 3 to the right. 1 up, 3 to the right. All right, so now I can graph this particular line. And it's easy because I graphed very nicely here to see the point of intersection. Right here. And the point of intersection is 3, -3. So that is my solution for this system of equations. So that is one method that we can use to solve a system of equations. All we're finding is that point of intersection. So let's do this. Let's go back to our notes and we go to page 2, and we're going to do substitution. And substitution uses our algebra skills instead of our graphing skills. And so here's my first example. And I have a system of equations. And actually, I have them graphed for you so that you can see that the point of intersection of these two lines is the point 5, 1. But we've got to go through the process of figuring that out algebraically. So the first thing we're going to do is we need one of our equations to either be y equals or x equals. In this case, I've got a y equals. And it happens to equal this, 6 minus x. What I'm going to do with this is substitute 6 minus x in place of y in the other equation. So it's going to go right here. And what I will have instead of x minus y equals 4, I'll have x minus, and make sure you put it in parentheses, 6 minus x equals 4. Now I have an equation that only has one variable in it, and I can solve for this variable. So the first thing I'm going to do is distribute my negative, and I have x minus 6 plus x equals 4. I'm going to combine like terms. X plus x gives me 2x minus 6 equals 4. Add 6 to both sides. And I've got 2x equals 10. Divide both sides by 2, and I have x equals 5. I'm not done though, because I need to know the y coordinate that goes with it. So in order to find the y coordinate, go back to this equation that says y equals 6 minus x. And what I'm going to do, since I know that x is 5, I'm now going to substitute 5 in place of x. So I have y equals 6 minus 5, which gives me y equals 1. And the way that I am going to write my solution is x comma y, which is going to be 5 comma 1. In parentheses with a comma in between, 5 comma 1. Now, just so you know, there is a way to check and make sure you have the right answer. The way that you check it is you have to do this 2 times. Go to your first equation, plug in 5 for x and 1 for y. If you get the same number on both sides, it's going to work in that equation. But that's not enough. You also have to do the same thing in the second equation. And you need to get the same number on both sides when you substitute 5 in for x and 1 in for y. You would get 5 minus 1, which is 4, and you have 4 on the right. So if you get the same number on both sides, it works in that equation. You've got to make sure it works in both equations in order for it to be a solution. All right, let's do one more example of this. So go down to example number 2, and again, this is graphed for you here, so we can see that the point of intersection is 0, -4, but we want to get that algebraically. We need one equation to either be y equals or x equals. If it isn't, you've got to use your algebra to make one of them be that way. This one has a y by itself. Y equals 2x minus 4. So I'm going to take 2x minus 4 and I'm going to put it in place of y in the other equation. All right, so what I have in that second equation now is 2x plus 3, and then in parentheses, 2x minus 4 equals -12. Notice I don't have any y's in this equation. I have all x's, so I can solve. So go ahead and distribute, and we get 2x plus 6x minus 12 equals -12. Combine like terms, and I get 8x minus 12 equals -12. Add 12 to both sides, and I actually get 8x equals 0. Divide both sides by 8, and that's going to give me x equals 0. And remember, you're not done just because you've gotten one answer. You've got to get both the x and the y. So now what we're going to do, go back to this equation that says y equals 2x minus 4 and plug in 0 for x. So I have 2 times 0 minus 4 equals y. And that gives me y equals -4. So my solution is x comma y, so 0, -4, in parentheses. I'll put a lovely box around it so you know that it is my answer. All right, there are some examples of substitution that you can practice with at the bottom of the page, but what I would like to do, since you have worksheet number 2 for homework tonight, is go to worksheet number 2 and let's start. So on worksheet number 2, at the top is just an example to remind you how to solve a system of equations using substitution. We're going to start with example 1. So example 1, it's interesting because both equations are y equals. That's okay. You only need one of them to be either y equals or x equals, and it doesn't matter which one. All right, so now, since both of them are, this creates multiple opportunities for us, but I'm going to go the easiest way. Since y equals x, I'm going to put x from the first equation in place of y in the second equation. And I'm going to get x equals -x plus 2. And now I'm going to solve for x. So get all my x's on one side, so let's add x to both sides. And I have 2x equals 2. Divide both sides by 2, and that's going to give me x equals 1. Now, we can go back to either of these two equations, and we're going to substitute x equals 1 to find out the y. So I'm going to go to the first equation because it's easier. It says y equals x, and x is 1, so therefore y must also equal 1. And I'm going to write my solution, 1, 1, in parentheses. All right, let's go to number 2 and do a second example. And again, I have two equations that are y equals. That's fine. I only need one to be that way, but since I have two, I can work with this. What I'm going to do is choose one of them, and it doesn't matter which. For example, let me choose the second one, y equals 3x. Since y equals 3x, I'm going to put 3x in place of y in that first equation. So I get 3x equals x plus 4. Get all my x's on one side, so subtract x on both sides. And I have 2x equals 4. Divide both sides by 2, and I get x equals 2. Now, I've got to go back to one or the other of these two equations, and it doesn't matter which. And I know, for example, that y equals 3x, and x is 2. So y equals 3 times 2, which gives me y equals 6. So my solution, x comma y, is 2 comma 6.